Welcome to video number 2 for this week. So before we start talking about Apache, the A in LAMP per se, let's talk about the protocol that Apache rides on, if you will. Remember, Apache is a web server, web application server software suite, and it uses HTTP as a protocol. So what do I mean by this? When you utilize or go to a web page, your client, your computer as a client is actually requesting its HTML. For example, it's asking for its HTML web page. So it's asking for HTML, but the protocol that it uses to do this, the protocol that it uses to make the request is HTTP, or if it's a bank or credit card or financial institution, you're probably going to be using HTTPS. Your computer knows which protocol it's going to use, whether it be HTTP, HTTPS, or FTP, or some sort of email protocol like POP3 or SMTP or Telnet or whatever. It knows it because each protocol has its own port number. So HTTP is port 80, HTTPS is 443, Telnet is 23, SSH is port 22. So just by the port number, it knows, for example, what format or what protocol it should be using. By protocol, because you may not know what I mean by protocol. So by protocol, I actually mean a set of rules and standards that define how devices or anything on a network could communicate or address each other. Sometimes it's informal, like when you answer the phone, you say hello. Or if you're in a business operation, I remember like when I was a teenager, I had to answer the phone business-wise, and I basically read from a script. I was like, hello, this is, ABC, Technologies or ABC Steel Company. How may I help you or something? So, and here's another example. There is a proper protocol for the simple aspect of seating at a restaurant. So you walk into a restaurant, you need to decide where you're going to sit. So you walk in, and really what you should be looking for is a sign that either says, please seat yourself, or please wait to be seated. You just don't walk in and sit anywhere you want, for example. Some rules are unspoken. For example, Catholics traditionally do not eat meat on Fridays. Some don't do it. Don't do it during Lent. And I have a friend who's so Catholic, he will refuse to eat meat on any Friday during the year, no matter what time of the year it is. So another example, the other day I found out I personally had a large unpaid bill, and before I withdrew the cash, I actually called the bank to make sure that they had the amount on hand, because I had always heard recently that banks are so sparse for cash that even if it's like $2,000, they may not have it all. So I made sure I did that. I remember at many house parties when I was in high school, you never went through the front door, for example. You always went through the side door, and you had to respect that because it was someone else's house. And now that I think of it, I think it has something to do with, the other neighbors were sensitive to house parties. And so if all the neighbors saw everyone going through the front door, they would be more likely to call the police. It literally just came to me right now, so maybe that's what it was. But a protocol is just a way of doing things. But in networking, there are precise fields that need to be placed or filled in a certain way. It's almost like a key value type of structure, a data structure, in which, for example, with an HTTP request, there's a specific field for destination IP, a field for source IP, and a field for source and destination MAC address and payload, and all of that. So as this relates to a typical web page running web server software, even if it's Nginx or Apache or IIS, Internet Information Systems, whatever the web page is, it's going to respond to a URL or Uniform Resource Locator, which takes requests and everything, and it has within the structure, it has many fields that have to be checked. And I know from a user's perspective, for example, we generally Google for, say, the latest GPU, such as the RTX 5090, or maybe a decently priced baking sheet. Now, this is an example that shows that there's so much that happens behind the scenes that we're not even aware of it. But as I said, imagine you're a user looking for the latest GPU, the RTX 5090, or the latest, maybe a sale on baking sheets, and you Google it, and it leads us via the Google results to maybe Target or Amazon or even Walmart. So it's going to display the competitively priced goods. So you click on it, and you magically go to that website. But what really happens is that the DNS as a service replaces your quote unquote click with your requested domain name, for example, Amazon.com, and it places Amazon's destination IP address, and it puts your source IP address in, and in the payload section, it maybe has the specific request for the specific web page itself, and then it takes you to the specific product ready to be purchased or ready to be looked at or whatever. Maybe you're going to put it on your wish list. But what really, really matters isn't really the details at this point. It's the architecture, if you will. It's the client-server architecture, meaning it's not peer-to-peer. In a peer-to-peer network, everyone has an equal chance, if you will, to perform or execute a given request for this particular protocol. And we see this in, Napster and things like that. However, there's client-server architectures. An example of this is a DHCP request. And if you understand I'm going to call that, if you understand the algorithm DORA, then you understand what DHCP is. But if you don't know what DORA is, then I urge you to look it up, because as a system administrator, your main job, unfortunately, will be looking things up on a day-to-day basis. If you're put on a project and you don't know what it is, you're going to have to Google it and get an idea of what it is. That being said, a DHCP request is client-server in that there's only one DHCP server, and your clients are at some point are going to need to make a request for an IP address, and it actually sends out a broadcast request to everyone, and only the DHCP server responds with an IP address, and the client actually then receives that IP address. Keep in mind, the idea is one to many, so there are many clients to one server, and that's the main difference between peer-to-peer and client-server. With peer-to-peer, everyone has an opportunity to be a provider of these services. With a client-server, you have one provider and many requesters. All right, today we are going to talk about HTTP, and before I read these other things here, let me just say that it's just not HTTP. We're going to talk about HTTP as a protocol, as how your computer or how a network would look at it. Next, we're going to talk about web software in general, web hosting in the cloud. We're going to be talking about Apache as web hosting software. We're probably not going to get into Nginx, but keep the knowledge that Apache and Nginx perform the same function. They're hardly equivalent to each other, but some people prefer Nginx, some people prefer Apache. Today, we're just going to discuss really Apache. Now, we're going to be taking some time talking about these things, and we're probably not going to have time to install Apache. We'll talk about that next week, but we're going to be installing the Telnet application suite. Now, the reason why we're starting with Telnet is because I want to introduce to you installing software, core software on Linux or whatever you're using, but I also want to talk about the implications or what you should look out for as and I want you to look at Telnet as a piece of web software and how it complies with Apache in terms of specific things. So let's move on and look at that first slide. All right, let's take a look at the LAMP server as it pertains to the internet, let's just say. So we have our stack right here. We have our Apache, and we have our middleware, which is PHP. We have MySQL, and then it's writing on Linux, so it looks like Ample, but it's actually a LAMP system. So what we're focusing here is on Apache, which is a web server. So as a web server, which is this right here, it's going to be just sitting there listening to different requests. So different clients, it could be 4 or 5 of them, or it could be hundreds of them all online. And this is where the dividing line is. This is like the internet. Now, it could be the internet as in the capital I internet, or it could be the lower I internet, which could be still within the company, maybe even a different LAN. Whatever it is, you're going to have multiple clients right here making different requests, and it is the server's job to negotiate these different requests, and it knows which one it is. It knows where to go because it caches all of these requests, and it takes note of the different port numbers that are available. That's how it knows where to respond to, where to send the information. So of course the server is going to have HTML, it's going to have information about database queries, and it's going to have caching information, and it uses port numbers to manage these requests. So let's move from this abstracted view to this next view that's a little bit more in detail. We have the request right here. We'll start off with the client, and the client's IP address is 171.41.72.6. I don't know what the subnet mask is, but let's presume it's going to be 24. So the network portion of the IP address, and I'll even put a red mark right here, is 177.41.72. And then the client part, let me put that in green, is the .6. So in other words, anything that starts with 177.41.72 will be within the same network. But we see that the request is going outside the LAN through the internet. So it's going to go through their ISP or internet service provider through the largest WAN or wide area network in the world, the internet, and it's going to ultimately land to this server. Now, maybe this server is Facebook, maybe it's Amazon, Alibaba, or anything else. And we can see here it has a different network ID and also, thankfully, a different host name, but it doesn't really matter. It has different network IDs. So naturally, it's going to go through the default gateway and out through the router and in through the largest WAN in the world, the internet. But let's take a look at the source address is 171 matches this, and the destination address matches this, and the port number is 3022. So we have the incoming port number is over 3000, 3022. Now the destination port number is a well-known port number, and that's port 80. That, of course, is HTTP. If it was 444, IA244 it would be HTTPS. And we have the response is the source is 80, and that's how it knows that the server, it uses the destination port number to manage all these different connections that are probably simultaneously coming in. Like, for example, you got Facebook. Imagine how many simultaneous requests there are for Facebook with all the instant messaging and all the posting on everyone's wall, all that going on simultaneously. Imagine, if you will, like for example, a simple weather application, weather.com. Think of how many people are basically checking the weather online. What about Amazon? Think about how many people are right now, checking out the latest and greatest product there is right now. So this is just the kind of like the layout or the trajectory, if you will, of the different connections. Again, we have different clients simultaneously making requests to the server. Each of these clients are going to have separate IP addresses. However, these differing IP addresses will be going to the same IP address of the server, and the server is able to basically dissect the request and look at the port number, and that is how it's able to differentiate between these various requests. And since we're on the subject of web server, the web server will have a front page or HTML that it's going to transmit within the actual response to the servers. And just so you know, the web page should look similar despite them being different client types. Here we have a laptop, here we have a cell phone, and here we have a standalone PC, and there's also tablets, and there's different clients like this. Most of the clients in 2025 are going to be rendering web pages on cell phones. Now, the cell phone will be riding sometimes on different technology, different infrastructure than these other clients, the laptop and the standalone PC. And through the magic of something called TCP/IP, in which you have different protocols riding on different technologies, because of the magic of TCP/IP, the web page will render basically the same on each of these devices. Variables include the type of web browser being used and whether or not the technology, or whether or not the actual origin, I'm going to call it origin syntax or code, uses things like responsive pictures and responsive code like that. So responsive pictures and images knowingly change according to the client's web browser, because it's able to detect whether or not it's a cell phone or mobile device, or whether or not it's an actual standalone laptop or PC. Okay, as was mentioned before, HTTP is the protocol for communicating on the web. So whether or not this server is a web server, I'll just put web here, WEB, which means it's an HTTP server, or whether it's a telnet server, which we're going to put together today, I'll just say T for telnet, or SSH, I'll just put an S, or anything like that, we know that it's there to sit on its behind, on its butt, and wait for different requests. So this client is going to make a request via an HTTP packet, which is going to request this server for the contents for example, if it's a web server, it's going to ask it for the contents of its web page. Now, there's different codes that are available, or methods, as they say. That a method, of course, is an action word. So, for example, there is get, and then there's post. So get retrieves data or resources from a specified URL. It's used to retrieve information without modifying it. So imagine you have a web page. It's got HTML on it, or you recall those HTML web pages. You recall those HTML tags, and within those HTML tags, it's going to have things like images and pictures and meta tags and syntax. And as I said, it could be anything. You could be going on to WallStreetJournal.com or DetroitFreePress.com. It's going to have video video. It's going to have embedded video. So GET is a special type of request that retrieves information, but without modifying it. Another method right there is POST. It submits data and it sends data to be processed to the server, often resulting in the creation of a new resource. So we have this. So every server, or most servers, are going to also have some sort of database, such as MySQL or Oracle database or something like that. And when a user doesn't go for the GET, but a lot of times the GET is used to retrieve the landing page, but if the user decides to navigate that landing page and go to where a blog is, or where he can send an instant message, that would be an example of a POST in which this same user posts a message to the server in their database, and then another user would basically simultaneously, who was signed in, would retrieve that message, that post. So that would be like a GET on their end. So for example, two users are logged into Facebook. One posts a message and the other one gets that message. So there is put, delete, so you can read this at your leisure. All right, let's take a look at as it says, the components of a stack, a typical HTTP stack. So these are various, I'm going to say types of devices that operate on the web that allow for a smooth web surfing and web experience. So when you go on Broadcom.com or your bank or everything, or any, high intensity site like ESPN, go to ESPN.com. You're going to see so many different sections or domains in the website. You have your score on the top, you have all the latest stories here, and you have all this information on the bottom, like it could be tournament results, it could be the latest NHL results. All of that is converging at one point in time on one single web page. You would be shocked if you went to ESPN.com and right-clicked and looked at the view code. You'd be shocked at everything that is required to bring all this information into one place. In order to do that, you need a lot of good infrastructural technology, a lot of good physical connections, a lot of fiber optic cables. But you're also going to have things like load balancers, application servers, web caching servers. So we're going to focus on these things right here: load balancers and web caching servers. Load balancers are able to leverage things like DNS and other things like that, things like I'm going to say algorithms such as round robin to determine the proper server that a request should go to. So in other words, you have a router or any layer 3 device, and you have all these simultaneous commands coming in, and there's only one web server. So if there's only, like I said, if there is one web server responding to these multiple requests, multiplexing is going to be fairly kind of costly, because you have this thing called a three-way handshake that exists with TCP/IP. So with TCP/IP, you have a system in place. It's called windowing, in which you have a request here, and then the server or destination has to acknowledge that request in order to there to be sequencing. So with sequencing, if a server receives simultaneous requests and one of the request segments, let's say, gets deleted by mistake or doesn't get processed, maybe it gets dropped, the server still needs to know the order at which he should be responding to the client with packages. So sequencing is needed for that, because if something's out of sequence, the client can quickly organize it. However, that requires sequencing as a thing, and with TCP type correspondence, that takes overhead. The three-way handshake takes overhead. So with all this overhead, this one server responding to these many requests might get a little, overwhelmed. So you have multiple servers that can potentially respond to the same type of requests, and this is done through load balancers. So load balancers exist between the router and the two servers, and the load balancer will take all of these simultaneous requests and divvy them up between the two servers. Okay, let's talk about web caching servers. So web caching servers take advantage of the fact that some tasks or some resources that are requested are the same. So for example, you take a web page and the frame of the web page might be the same, but the images and text might just be the only differences. So a web caching server will cache or save the overall framework of the web page and just send and receive the different images and the different text. That's an example of how a web caching server actually can save time. Another example of it is companies specifically meant to process overly, I'm going to say, image intense materials, such as the company Akamai, and I think it's we'll just say AKAIMI, although I'm sure I'm not spelling it right. Akamai is an actual company that has different locations all over the United States and all over the world, actually, and a company like Amazon or Red Hat or GM or Ford or whatever, they will actually send out certain protocols to Akamai servers, such as video calls and things like that, to stream and smooth out the requests. So as I said, that three-way handshake can be kind of I'm going to say inefficient, but however it's needed, and load balancers are there to, relieve the effects of the three-way handshake. But what about, when you have a gig link or less than a gig link? Let's say you had 100 megabits, a fast Ethernet link. I was going to say 100 megabits a second. What if you had that, but there was like a lot of video calls? So you would configure your switch or router to send out the video signaling or the video calls or the video, I'm going to say video requests to companies like Akamai that will use caching or whatever their technology does to smooth out the stream so that the destination just gets this smooth video and it is able to circumvent the slow connection and, tangentially almost like send the signal to the Akamai servers, and the Akamai servers will then send the smooth video stream to the destination. So companies like Netflix and Apple TV probably use Akamai to smooth out your video playback. All right, let's talk about the various types of, I'm going to say, cloud infrastructure. We have the traditional type of infrastructure in which all the applications and data is on-prem, meaning it's all on-site. So you have a big building right here, and let me do my horrible version of what a building looks like. And we have your servers, and the servers are presenting or serving an application, and all the data is served in the same cluster or in the same, I'm going to say, stack. Does that look like a tank? It looks like an army or it looks like an army tank or something like that. I'm just saying this is the application server. It might be running some type of an Nginx or Apache or something like that. And here is the data that the application uses to either present to the user or the user posts to the data right here. It's all under one roof. Now, infrastructure as a service, okay, is when, everything is managed by you, okay, and the server provider provides everything in this stack, okay? So in other words, you're pretty much doing everything yourself. It's just that the service provider is running the infrastructure, hence infrastructure as a service. So in other words, they are providing for you the storage, and you are providing to them everything that the storage does. You're providing them, basically all the compute. Okay, so it comes down to the notion of power, it comes down to the notion of compute, and it comes down to apps. Okay, so in infrastructure as a service, they are providing the power, okay, meaning the networking, storage, servers, and virtualization. You are providing the computing power and the application. So basically the middleware and the application server. So that's infrastructure as a service. When it comes to platform as a service, okay, in this particular case, they are providing the power and the compute, and you're just doing the application side. So in other words, they're providing you all the processing power, all the data, all the servers, and they present to you basically a sandbox. So platform as a service allows you to basically take a blank piece of paper or a blank slate, and you tell them how you want to present the blank slate. So they tell you, here are the databases, and you tell us what you want us to do with the databases. And then we have software as a service, in which they control the power, the compute, and the application, and you subscribe to that application. So an example of this is Google, Dropbox, Gmail, Netflix, anything that we subscribe to, Xfinity, everything. Platform as a service is an example of platform as a service is called ServiceNow, in which you can subscribe to ServiceNow, and they provide you different things you can do with it. Maybe you want them to keep track of your employment records. Maybe you want them to do payroll. You tell them what they want you to do, and you control it. Infrastructure as a service means that all they do is they supply the power, and you supply the compute, and you configure the applications. Okay, so we are going to demonstrate some of the details of installing a program on the HTTP level, and we're going to be installing Telnet. Now, Telnet is a way, and I'm just going to draw this poorly presented server right here. Telnet is a way that a client can request to log into the server remotely. So here is the server right here. I know that looks like it's an Apple or Dell, one of the two. So imagine, if you will, you're not physically at the server location. You are in your own home, or maybe the server is in another state. Let's say you work for Ford, GM, or whatever, and the server is in Canada or California or anywhere like that. It could even be in China, and you're not going to fly all the way to China or Germany or Dubai or wherever to actually physically program the server. What you're going to do is you're going to log in via Telnet into the server, and you're able to program it, at least get to the command line interface from wherever you are. So that's a big time saver. So that's what Telnet is. So let's go ahead and configure it on our Debian, Linux, or Microsoft Windows server. So as I said, we are going to install Telnet on our server. And to install on a Debian Linux server, basically it's one command. And this is the server side. So there are two sides. They say there's two sides to every story, but there are two sides. So there's the server side and there's the client side. Now on the Telnet, on the Linux side there, when you install the server, I believe you also install the client. Now on Windows, Microsoft Windows, it's a whole different story, and actually the default version of Windows 11 does not come with Telnet activated at all, so you have to activate it. Now it comes with a possibility of activating it because it is in programs, but again, I have attached to the documentation this week, I have attached a link for those of you that do have Windows 11 clients that you can download or you can activate demonstrate Telnet on Windows 11. MacBook, I hate to say it, you're on your own. But what I'm going to demonstrate it to you on my computer is because of the fact that I was able to install Linux with UTM or VMware, in my case, VMware Fusion. I'm able to basically bring up Linux on my MacBook and on the same machine bring up another instantiation of a client, and I could either do Linux or Windows, and I did Windows because I was able to figure out how to install Windows 11 on this ARM architecture, and I'm going to demonstrate that to you. But you can do it however way you want on your end. Okay, like I said, like I was about to say, to install Telnet, you do apt, and you don't even have to do apt get. Just do apt install telnet d, and then the -y is to make sure you just say yes to it. And then to check it, system control status init d, because the root of telnet d is netd, so status inet d. So let's go ahead and take a look at, oh, you know what? Let me bring this in. I don't even know if I almost did it off screen. So let's take a look, and we can do, the first thing we can do is we can take a look at the listing of all our current packages. So apt lists all the current packages, but look at that. Look at all those packages that we can see. Now, the whole point of doing, what was the last command that I did? Apt list is we can do grep telnet to see if there's any packages with telnet installed, and we can see there's a bunch of packages with telnet installed. So we may sense that, we may not need to install it, but just to be safe, we can still do sudo apt install telnet d-y. I'm going to press enter, even though I already have it installed. And it says that telnet d is already the newest version. Now, the d that it shows here refers to the fact that it's the server version of telnet, because as I said, there's two different versions of telnet and SSH, which is something similar to telnet. There is the D version, which is the server version, and then there's the one without the D, and that's the client. What we're worried about is the server version. So we've already made sure that we've installed telnet D. Let's go ahead and take a look to see what the status is. And of course, you have to type in system control status inet D. And oh, just so you know, also, even though my documentation said apt get install telnet D, this you can see we don't need get, we can just do apt install. Anyways, we can see that the status is that it's running. I'm going to type in Q to end this, and then I'm going to show you something kind of cool. One second, because I have to readjust the vision here. One second. Okay, these are my two PCs, my two virtual OSs that I have up and running together. We have Windows 11 ARM version beyond VMware Fusion. These are both using VMware Fusion, and I have my Debian right here. So we just have shown that the telnet is running on my Debian server. Now, before I even do I can do ifconfig or sudo ifconfig. Now, before I can even do that, we have to install the package, and I know what it is because I installed it earlier, and that is nettools. You have to do sudo apt install nettools in order for you, and I'll even do it right now, and it says I have the newest version installed. In order for me to do sudo ifconfig. Now, when I do sudo ifconfig, we can see that my IP address is 192.168.1.53. Now, the reason why it's within the same scope of my local network is if we go to virtual machine, and I'll do that that in the next little segment right here. Let me just show you here. Now we'll go to my Windows right here, and we'll go to Start, and we will go to PowerShell. Go to PowerShell. If it ever comes up, here we go. It comes up, and we can do ifconfig, and we can see that, oh, it doesn't, it's not recognized. I apologize. Let me type in clear, as in clear the screen. It doesn't even like clear. What is going on? I'm just going to close this out, because the one thing I want to show you is that I'm going to do CMD to get to the command line. I'm going to do ipconfig/all, and we can see that my IP address is 192.168.157. So in other words, it's within the same broadcast domain right here, because they both start with 192.168.1. Now, from here, let me go to Windows PowerShell, and I'm going to ping. The first thing you should do is ping the destination telnet server to at least make sure you can ping to it. Now that we're sure that we can ping to it, we're just going to telnet to it, and it asks for my login and asks for my password, and bam, I have now logged into my remote server via telnet, and here are some commands that you might know. pwd, who am I? There we go. Okay, so that has been accomplished. One more little snippet about how we can accomplish this. I'm looking at the very top of my machine because this is a MacBook. And we can see at, when I click on this, we can go to this. This is VMware Fusion. So we can click on this, left click once, and we can go to network adapter. And please be in bridged Wi-Fi network, because if you go to NAT or something, it's going to give you an IP address that is private, but yet out of your local IP address, local area network. Same thing with here with Debian. We go to virtual machine and we go to network adapter, and again, it's at bridged. Well, this is bridged auto detect. So you want to make sure that in both cases you are in your bridged network. And then before, even though you're going to have telnet server and client installed respectively, you want to make sure you can ping one another before you attempt a telnet, because if you can't, then you can at least isolate one of the issues. Good luck. Good luck.